Welcome. Let us go through structure and bonding. But here I'm going to basically concentrate on bonding. So we want to find out what is a bond first. So the meaning of structure and bond. So let us see, what is a bond? The mutual force of attraction that holds particles together when atoms combine during a chemical reaction is what we call a bond. So a bond is a mutual force of attraction that holds particles together when atoms combine during a chemical reaction. So a mutual force that is holding particles together. Therefore, that is the definition of a bond. Like I said, I want to concentrate on the bonds. So there is what I've given here, that this is supposed to be laying up the foundation of bonding. So for us to understand what are the types of bonds and how bonds occur, there are basic things that you must have in mind. So you should be able to identify and differentiate, very important, between metals and non-metals. So if you don't know that this is a metal, this is a non-metal, then it is going to be very difficult for you to know which bond is this, which bond is between the compound given. Therefore, that's why I prefer taking you through the periodic tables slightly, so that you can see, we can understand which element is a metal and which one is a non-metal. Therefore, let us look at the only thing you need to know is the electron configuration. Hydrogen is a non-metal. Helium is a gas. These are gases. These are group 8. They are gases. Argon, all these are gases. We go to radium is a metal. How do you know? When you write an electron configuration and the outermost energy levels, is that element gaining electrons or losing? So for example, for lithium, it will lose 1 electron, therefore it is a metal. Beryllium, it will lose 2 electrons to be stable, it is a metal. Boron will lose 3 electrons to be stable, it is a metal. Carbon is a metal or a non-metal, so that one, leave it alone. And silicon, you leave the group 4, you leave them alone first. Nitrogen, is it a gas or a solid, or a liquid, or is it a metal or a non-metal? Is nitrogen a metal or a non-metal? Let us look at the electron configuration. 2, 5. So what will happen during the chemical reaction, or when it wants to become stable? It will gain 3 electrons to have a stability of 2, 8. Therefore, an element which gains electrons is a non-metal. Take it like that. An element that gains electrons is a non-metal. Oxygen, look at oxygen, is a non-metal. So it is 2, 6. Therefore, it requires 2 electrons to be stable. It will gain. Fluorine is a non-metal. It will gain 1 electron. So that's how you know a metal and a non-metal. Once you have differentiated, once you know this is a metal and this is a non-metal, it is going to be very easy for us to tackle bonding. Other metals commonly used not found in the first 20 elements include, but not limited to, zinc, barium, lead, iron, silver. So these are other metals which we don't have, but you will find when somebody asks you, what is the bond between zinc chloride? Zinc chloride, what kind of bond is that? So zinc oxide, what bond is there? So that's what I have written here. We have some other non-metals which are not in the first 20 elements, but we use them, iodine and bromine. They are in group 7. So they are non-metals. Very good. So another thing we want to look at is the nature of the chemical bond. Atoms are made up of energy levels. That is another thing you need to understand, energy levels. So in an atom, let me take you through this atom. This is an atom. An atom is made up of 2 major regions, that is the nucleus and the outermost energy levels. These lines, these are called the outermost energy levels. So in the energy levels we have electrons, and in the nucleus we have the protons and the neutrons. Very correct. energy levels, in the energy levels we have electrons. In the energy levels we have electrons. So as you can see, the nucleus contains protons and neutrons, and electrons are out here for helium. So why is that important? Atoms are made up of energy levels. So during chemical bonding, we use the electrons in the outermost energy level. So if you don't know the outermost energy level, then it becomes very difficult. The electrons are negatively charged, protons are positively charged, while neutrons are electrically neutral. Very important to note. The noble gases are chemically inert since their outermost energy levels are completely filled with the maximum possible number of electrons. It means that this here, they don't react because helium does not react because it is stable. The electron configuration is already filled up. Neon does not react because it is already filled up, therefore it is stable. Argon does not react because it is already stable. That's what we are given here. Thus, noble gases have either a stable duplet is 2, like helium, and a stable or an octet configuration, which is 2.8 or 2.88, as in neon and argon respectively. Other atoms are unstable, mark that. The rest, which does not have the electron configuration of this, they are unstable. If they are unstable, they must react for them to become stable. So during the reaction, they will either lose electrons or gain electrons. So other atoms are unstable because the outermost energy level, mark that, because the outermost energy levels are not yet completely filled with the maximum possible number of electrons. Why do they react? Because the outermost energy levels are not yet filled up completely with the maximum number of electrons. That's why they react. Therefore, to attain the stability of the duplet or the octet, to attain that, what will happen? Such atoms either lose electrons, or gain electrons, or share electrons. So they will either lose, gain, or share. Very important. Now we are narrowing down to what we were supposed to do, bonding. If you don't have what I'm saying, then bonding becomes difficult. So don't jump into bonding when you don't have this basic information. It is the act of losing or gaining or sharing valence electrons that leads. Are you getting that? That leads to what? To chemical bonds. So if you don't know which element loses electrons, which one gains, why should the others share, then it becomes difficult for you to master this. So it is because of losing electrons, gaining electrons, or sharing valence electrons. Valence electrons, these are the electrons in the outermost energy level. Valence electrons is the electrons found in the outermost energy level. Once you have written the electron configuration, the electrons which are outside the outermost energy level are the ones that are responsible for chemical bonding, not the inner energy levels. When atoms gain or lose valence electrons, they become charged, forming anions and cations respectively. That's not very important. Now, there is a note here which I consider very, very important. During chemical bonding, only electrons in the outermost energy levels are involved in bonding. I don't know how I can put it in other words, but I hope you have understood that electrons in the outermost energy levels, they are the only one involved in bonding, not any other outermost energy levels, only. I want to bring you back to this periodic table again. Let us look at this periodic table. So when these atoms are forming bonds, we consider the outermost energy levels. Here we have 1, 2, 3, 4 energy levels. Therefore, the outermost with the 2 electrons, it is what will be lost or gained, depending on the element. Potassium here, it has 1 electron in the outermost energy levels. It has how many energy levels? 1, 2, 3, 4. The outermost is the one that we consider. Oxygen has 6 electrons in the outermost energy level. So this is what we call the outermost energy level. For argon has 288. It has 3 energy levels, and the outermost energy levels contains 8 electrons. Therefore, it is maximum. It will not react. It will not lose. It will not gain anything. So I hope you have understood the outermost energy levels. They are the one that are involved, that are used during chemical bonding, the outermost energy level. So you must write the electron configuration for the elements involved, and then see whether they will gain, they will lose, or they will share. Very good. Types of bonds. There are 3 main types of chemical bonds. There are 3. We have 3 main. There could be others, but we are talking about main. We have hydrogen bonds, we have other bonds, but the major bonds, we have 3 of them. That is the ionic bonds, covalent bond, and a metallic bond. So you could be worried, where is dative bonding? Where is the coordinate is called? So coordinate is a type of covalent, therefore we don't include it. It is not a type. We have only 3 major, that is ionic bonds, ionic bonding, covalent bonding, and a metallic bonding. Those are the major bonds that we have. So ionic, we will start with ionic bonding. Ionic bond is also called electrovalent bonds or bonding. Ionic bonding is also called electrovalent bond. Why is it called electrovalent? Because here we have a complete transfer of valence electrons from one atom to another. So the meaning of ionic bond means, so what is ionic bonding? Is a bond formed due to complete transfer of electrons from one atom to another, resulting into 2 positively charged ions. So one loses electrons and another one gains the same electron that was lost. So they form a mutual electroforce, and they combine and they stick to each other. So another very important information I want you to have is this. So how will you know that this one is an ionic bond, this one is covalent, or this one is? So the ionic bond is formed due to complete transfer of electrons from one atom to another, and mainly, now this is where I want you to mark this, and mainly between metals and non-metal. That's why I wanted you to know what's a metal and a non-metal. For example, when we have sodium chloride, if I ask you what is the bond between sodium chloride is a salt. The bond between them is ionic. Why? Sodium is a metal, chlorine is a non-metal. What is the bond between magnesium oxide? What is the bond between magnesium oxide? Magnesium is a metal, oxygen is a non-metal, therefore the bond is ionic. So that's why it is important to note. Therefore, magnesium transfers, remember, here the electron configuration of oxygen is 2 to 8 to 6. Fine. Magnesium is 2 to 8 to 2. So see this. Magnesium has 2 electrons and it is unstable, so it will lose the 2 electrons. The 2 electrons are needed by oxygen for it to be stable. So oxygen takes these 2 electrons. So these 2 electrons are transferred to oxygen directly. All of them are transferred, so that oxygen now becomes stable by 8, and this one becomes stable by losing 2. So both of them become stable like that. I hope now you understand what we are doing here. This occurs in the bid of both atoms to acquire stable noble gas configuration. One atom one atom loses all its valence electrons, thus forming a cation, positively charged ion. The other atom gains all the lost valence electrons, forming an ion, negatively ion. You have seen I've already given an example of magnesium and oxygen. Magnesium loses all the valence electrons, which are 2, and the 2 valence electrons lost from magnesium are regained by oxygen immediately. So oxygen forms a negatively charged ion, magnesium forms a positively charged ion. That is what we call ionic bonding. The cation and the anion are positively charged and thus develop a mutual force of attraction between them, which is an ionic bond, electrovalent. Because it's negative, positive, they attract each other. Like terms, like they call in physics, they say like charges attract, and unlike charges attract, like charges repel. So because it is negative and positive, they attract one another and they form a mutual force of attraction which brings them together, forming a bond, and the bond is called ionic. I have some illustration here. Illustration: formation of ionic bond between sodium and chlorine. Sodium is a metal, chlorine is an nonmetal. Chlorine is an nonmetal. So how do they form their bond? Sodium is atomic number 11, has electron configuration of 281, and thus unstable with 1 valence electron. So what will happen? It has to lose 1 electron here. Chlorine is atomic number 17, has electron configuration of 287, and thus unstable with 7 valence electrons. So chlorine needs 1 to be stable, and sodium needs 7 to be stable. But it is very difficult for sodium to gain 7. But it is easier for it to lose 1 so that it becomes stable. Chlorine, it requires a lot of energy to lose 7 electrons to become stable. Therefore, it needs to gain 1 to become stable. It is easier to gain 1 electron. So that's why sodium is more electropositive. Electropositivity means that it is easier to lose electrons than chlorine, while chlorine is more electronegative. Electronegative means it is easier to gain electrons. So sodium loses its zinc valence electrons to form sodium ion with electron configuration of 2 to 8 and have a positive charge. This is what we call a positively charged. Chlorine atom accepts a single electron lost by sodium to form a chloride ion, with electron configuration of 288, and it becomes negatively charged. Very good. So the positively charged sodium ion and the negatively charged chloride ion attract each other. They attract each other. The electrostatic force of attraction develops between the 2 positively charged ions, and this constitutes the ionic bond. So compounds formed due to ionic bonding are called ionic compounds. Very, very important to remember that ions like sodium chloride, ions like magnesium chloride, zinc chloride, they are called ionic bond because ionic compounds, because they in between them they have ionic bonds. The exception is here. Aluminum chloride, that's where I want you to get. Aluminium is written like this: aluminium chloride. Aluminium chloride is written like that. So my question to you is this: is aluminium, what kind of bond that is between aluminium? From a glance, you can look at it and then you tell me that it is a covalent, it is an ionic bond, because this one is a metal, aluminium is a metal, and chlorine is an nonmetal, therefore it is ionic bond. So with an exception of aluminium chloride is a molecule. Therefore, you should know that aluminium chloride contains dative bonding. Therefore, you leave it out. That's why I've given you except aluminium chloride does not fall under the category of zinc chloride, magnesium chloride. No, this one is very different and very unique, very important. So diagram, we can represent what sodium in terms of the diagram. For ionic bonding, sodium atom has a electron configuration of 281. Chlorine atom has a electron configuration of 287. Chlorine needs 1 to be stable. Magnesium, Sodium needs 7, but it will lose 1. So sodium will lose 1, and the 1 lost electron will be gained by chlorine to be stable. So when now to the right side, this is the left side, this one is the left side. On the right side, here we will have sodium has lost 1 electron, and it becomes positively charged. Chlorine gains 1, and it becomes negatively charged. You can see here it becomes negatively charged. So this is how you represent when you are asked using dots and a cross represent the diagram for the bonding of sodium chloride. This is the expectation. This is how you are supposed to draw them. So other ionic compounds which will do the same, so potassium fluoride, magnesium iodide, those are there, aluminium trioxide. So I have given also the dot and the cross diagram for ionic compounds such as potassium iodide. Potassium is atomic number 19, so electron configuration 2881. So it will lose 1. The lost 1 electron will be gained by fluorine to have 28. So this is how you represent. Now, what is the difference? Potassium here has lost the outermost energy levels. It has remained with 1, 2, 3 electron energy levels. Fluorine has gained 1 electron from here. We use X dot to differentiate the electrons of fluorine and the electrons of that is gained from potassium. So that's why you see dots and X are the same, because X represents the electron which has been gained. And that is what we call potassium fluoride now. When an element loses an electron, it becomes positively charged. When an element gains electrons, it becomes negatively charged. So magnesium oxide also, so you can see this, and then practice. We can have magnesium. So the one I want you to draw, you draw, and you can WhatsApp. My number is also there. You can draw the aluminium oxide and send to WhatsApp so that I can see what you have done. Aluminium trioxide, try to draw it. Draw the dot, and using the dot, the question is using dot and cross diagram, draw the bonding of aluminium chloride, aluminium oxide. So you will try that. So let me take you through covalent bonds and the coordinate bond, because coordinate bond or rotative bond is a sister to covalent bond. Now, what is the definition of covalent bonding? What is a covalent bond? What is a covalent bond? A covalent bond refers to a bond formed when two atoms of the same or different elements share. That's where you need to understand. Now here there is no complete transfer of electrons. Here it is sharing of electrons. I said the complete transfer is between a metal and a non-metal. But for covalent bonding, it is a bond which occurs between non-metals. Non-metals, they react by gaining electrons. So none of them, the non-metals which is going to give out electrons. Therefore, both of them, they will share the electrons to become stable. Refers to a bond formed when two atoms of the same or different elements share electrons to become stable. Covalent bonds are usually formed by the association of non-metals. Very important. Now, imagine you don't know what is a non-metal. You don't know examples of non-metals. How will you tell that this one is a covalent bond? Formation of covalent bond between atoms result to the formation of a molecule. Result in the formation of a molecule. In Form 1, you must have defined what a molecule is. But if you have forgotten, a molecule is a group of atoms of the same or different elements that are held together by strong covalent bonds. That is a writer or a simple definition of a molecule. When two atoms of oxygen atoms combine, they form a molecule. So oxygen, the one you see we write in a periodic table like this, oxygen, this one is an atom. So oxygen plus another oxygen, it forms what? It forms an oxygen is a molecule. This oxygen is called a molecule, and these ones are atoms. So an atom plus an atom, it forms a molecule. But now look at this oxygen here. This oxygen has a valence of 2, electron configuration of 2 6. This one also have a 2 6. Which one will give electrons? None of them will give electrons. Therefore, they will share to form this molecule. They will share the electrons to form this molecule. So most gases are examples of molecules. Very correct. That most gases, oxygen is a gas, ammonia is a gas, nitrogen is a gas, chlorine is a gas, carbon 4 oxide is a gas, and so many other gases are what? Are molecules. Therefore, they form covariant bonding. They form covariant bonding. So when you are asked, what is the bond between this? What is the bond between this compound? You don't have to think twice. Nitrogen is an nanometal. Hydrogen is an nanometal. Then therefore the bond is covariant. Did you hear that? Yes, you have heard that. That chlorine is an nanometal. An nanometal these are atoms of chlorine. So this is chlorine. This is chlorine. Chlorine plus another atom of chlorine plus another atom of chlorine that gives us chlorine gas. So how do they combine? This is an nanometal and an nanometal combining together to form chlorine, to form a molecule. The bond is covariant. So it is important that covariant bonds, these are bonds between non-metals, except, I want to give you the exception. Now, I've given you that carbon 4 oxide is a covariant bonding, which is very correct. But what about carbon 2 oxide? What about carbon 2 oxide? Carbon 2 oxide will undergo dative bonding. So carbon 2 oxide, except with an exception of carbon 2 oxide, comma, with an exception of aluminium chloride, these two, they undergo dative bonding. This one, they undergo what? Dative bonding. And you should know what is dative bonding, as we are going to define. It is a type of covalent bond. So they will share electrons. At the end, another one atom will provide the electrons to be the pair to be shared. So we will talk about that. So with an exception of this, the rest of the nanometals, they will form covalent bonds. Nanometals will form covalent bond, but CO, it is a dative bond. It will end with the dative bonding. Formation of a covalent bond. Covalent bonding is brought about by the fact that the electropositive and electronegative of the elements involved are very close. For this reason, none of the atoms can completely lose its valence electrons to the next atom. That is very true. The nanometals are not willing to lose electrons. They want to gain. So therefore, none of them is willing to give electrons. For this reason, both atoms donate electrons, which are then shared between them. For example, in chlorine molecule, 2 chloride atoms combine for chlorine molecule. Both atoms thus gain stable noble gas duplet octet configuration. So this one here, I will draw a lot of examples. So let me give you the examples of, okay, before that, for oxygen atom has electron configuration of this. Where does it start? Yeah. For oxygen atom has electron configuration of 286 and thus need to gain 2 electrons into outermost energy level to attain stability gas configuration. Since both oxygen atoms have same electronegative, none will easily lose an electrons to the other. For this reason, both donate the number of electrons required by the other atom which they share between them. Thus, oxygen molecule is formed by sharing 4 electrons between the 2 chlorine atoms, hence a double covalent bond. So we are going to look at that and draw that. Thank you. No, there's a note here that a single covalent bond is represented in a dot or cross X diagrams using two dots. So when you see two dots or two crosses, it means that that's a single covalent bond. A dot and a cross or a single line like this between two atoms involved in the bond means a single covalent bond. Thus, a single covalent bond like in chlorine can be represented as chlorine dash chlorine. So this is a single, this single dash you are seeing here that I have highlighted with red is a single covalent bond, 2 electrons. A double covalent bond like in oxygen can be represented by 2 dashes like that, and this it represents 4 electrons, 2 2. While a triple covalent bond like in nitrogen is represented as that. So I am sure when we are going to draw these things, you are going to understand even better because I'm going to draw them. Now, some of the compounds that undergo covalent bonding is the gases. I've told you most gases, in fact all gases, they undergo covalent bonding. Hydrogen is a covalent bond, single covalent bond. Hydrogen chloride is a covalent bond. Nitrogen is a triple covalent bond. Water is a covalent bond. Water is written as H2O. So this one is covalent bonds because it involves nanometals, as you can see. These are nanometals for water. Carbon dioxide is a covalent bonding. Therefore, we are going to draw all of this. I'm going to take you through drawing these ones and you will see how simple they are. Let us move down. So ammonia, these are all elements or compounds that undergo covalent bonding. All of these. So we are going to try and draw all of them and you will see how simple it is to draw this because it is an nanometal and a nanometal. You have not seen any metal here. Then the last thing I want to talk about is the coordinate bond, which we also call dative bonding. Dative bond. Coordinate bond is a dative bond. But once you have understood a covalent bond, then dative bond is very easy because it is just a sister to covalent bonding. So what is dative bonding or coordinate? It refers to the type of covalent bond. You hear that? It is a type of covalent bond. So if it is a type of covalent bond, first they will share electrons. They will share up to a point when the other atom fails to have enough electrons to be shared. Therefore, another one now which contains more electrons will just donate the 2 electrons to be shared. So this is referred to a type of covalent bond in which the shared pair of electrons forming the bond is contributed by only one. That's where the thing is contributed by only one of the atoms forming the bonds. Unlike in the covalent bond, both atoms they provide electrons to be shared. But in dative bonding, it is only one atom that will provide a pair of electrons to be shared. So when we will draw this, you will see and understand very well. I know you will understand once we start drawing the dative bonding structures. So another thing I want you to know is the examples of elements or compounds that form dative bonding. One of them is the ammonium ion. Ammonium ion is written as NH4 then positive. So this is an example of a dative bonding. And I want to explain what it means for ammonium ion to be like this. I want to put this one to be like that, and this one should be the subscript like this. So ammonium ion, when we have a positive sign there, so any compound you see that contains a charge, that contains a positive there up, this positive, always don't think twice. That one will undergo dative bonding. It will go covalent to covalent and then finally dative. So whenever you see a compound with a positive, remember remember that compound will undergo dative bonding. So that's one of the things you must check. So another thing, so look at that, that's ammonium. We'll go and through that. We will draw the structure there. You will see, I will draw all of them. And then another one is hydroxonium ion. Look at this, it has a positive charge. So this is another example of a compound that undergoes dative bonding. So I've told you that look at the compound. Any compound which has a positive charge will undergo dative bonding. I will explain when I will be drawing the structures. When I will be drawing the structures, I want to just give examples. We have more other examples. So I will give you more other examples. We give you more other examples. Further example for dative bonding is carbon 2 and not carbon 4. Carbon 2. So carbon 2 is the only odd one out. This one you have to master that. Carbon 2 will undergo dative bonding. Except carbon 2 and aluminum chloride, which is a dimer. These are the two compounds which will undergo dative bonding, unlike the rest. So this one is an unimetal and an unimetal. So somebody could imagine that it is going to undergo covalent bonding. No, it will undergo covalent and then finally dative. So carbon 2 oxide, master it like that it will undergo. So this is pH, this is phosphorus H4, because it has a positive charge, it will also undergo dative bonding. So I've told you these are the examples which you must have in mind. You must have these examples in mind so that you can be able to. So the next bit of I will now take you through how to draw these structures, and I will be explaining more while we are drawing. I think up to this point we will leave it at this point, and then I will now give the structures and we will draw all of them together, and we will be able to understand better.